Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is evaluating a function. In our previous series, we were discussing what is a function, when a relation is a function, when a relation is not a function, can an equation be a relation. Now, we are going to work out how to evaluate a function. To learn about this topic, we need to move on to something called function notation. Function notation will be used heavily throughout in most of the remaining topics. So it is important to understand it. So let's start off with the following quadratic equation. We can use a process similar to what we used in the previous video, the examples that we discussed in our previous video. For more information about what is a function, you can refer our previous video and post all your comments in my comment section. Okay. So this is a function. We will note it as follows. I'm going to rewrite the left side as f of x, since this is a function. So we replaced y with the notation f of x. This is read as f of x. Note that there is nothing special about the f we used here. We could just have easily used any of the following. You can use, let me write it on the board. G of x, h of x, r of x. The letter we use does not matter. What is important is the parenthesis along with x part. The letter in the parenthesis must match the variable used on the right side of the equation, right side of the equal sign. Okay. It is very important to note that f of x is really nothing more than a really fancy way of writing y. Okay. If you keep that in your mind, you may find that dealing with function notation becomes a little easier. Also, this is not a multiplication of f by x. Okay, this is just for the initial learners. This is one of the more common mistakes people make when they first deal with the functions. This is just a notation used to denote functions. Next, we need to talk about evaluating functions. Evaluating a function is really nothing more than asking what is the value, what its value is for specific values of x. Another way of looking at it is we are asking what the y value for a given x is. So evaluation is really quite simple. Let's take the function we are looking at the above. I'm going to take this function and let me take one example. What its value is for x is equal to 4. In terms of function notation, we will ask this using the notation f of 4. So, when there is something other than the variable inside the parenthesis, we are really asking what the value of the function is for that particular quantity. Now, when we say the value of the function, we are really asking for what the value of the equation is for that particular value of x. Here it is f of 4. Just replace all x by 4. 4 square minus 5 times 4 plus 3. So, 16 minus 20 plus 3, which will give you -1. Notice that evaluating a function is done in exactly the same way in which we evaluate equations. All we do is plug in for x whatever is on the inside of the parenthesis on the left. Here is another evaluation for this function. Now I have taken a negative number. Same as the previous one, replace all x by -6. So you should know all the rules of signs for multiplication, addition, division. So we will get 36 plus 30 plus 3, which is equal to 69. So again, whatever is on inside the parenthesis on the left is plugged in for x in the equation on the right. Hope you're clear with this example. Okay, let's take a look at some more examples for different kind of functions. I have taken two functions, two completely different functions. F of x is equal to x square minus 2x plus 8. G of x is equal to square root of x plus 6. If you want to check whether this equation is a function or not, you can refer a previous video and work out the same method. You should get one value for unique value, y value for each of the x. If that is true, then you can say that the equation is a function. Okay, let's come back to this example. Here is the first part of the equation. We have to find f of 3, g of 3. So we have got two functions evaluations to do here, and we have also got two functions, so we are going to need to decide which function to use for the evaluation. The key here is to notice the letter that is in front of the parenthesis. For f of 3, we will use the function f of x, and for g of 3, we will use g of x. In other words, we just need to make sure that the variables match up. Okay, here are the evaluations for this part. Just replace all x by 3 in the function f of x. So I'm getting 9 minus 6 plus 8. So totally I'm getting 11. Same way for the next function g of x, replace all x by 3. So you have 3 plus 6 under the radical, which is equal to 9. Square root of 9 is 3. Hope you're clear with this example. Okay, now let me take some negative numbers. So this part is pretty much the same as the previous part, with one exception that we will touch on when we reach that point. Here are the evaluations. Replace all x by negative 10. So you'll get, I'm getting 128. 100 plus 20 plus 8, 128. Please make sure that you deal with the negative signs properly here. Now the second one, g of negative 10. So negative 10 plus 6 is negative 4. We are now reached the difference. Recall that when we first started talking about the definition of the function in our previous video, we stated that we were only going to deal with the real numbers. In other words, we only plug in real numbers and we only want real numbers back out as answers. So, since we would get a complex number, if you're taking a square root of a negative number, obviously you'll be getting an imaginary number, right? So, we can't plug in negative 10 into this function. Okay. Now let me take another example. For the same set of equations, I'm going to take 0 as x value. Let's see how to evaluate that. So 0 square minus 2 times 0 plus 8. So that will give you 8. Again, don't forget that this is not multiplication. For some reasons, students like to think of this one as multiplication and get an answer of 0. So please be careful with these types of problems. Now let me take a variable for x. Let x is equal to t. So this one shows we don't need to just have numbers in the parenthesis. However, evaluation works in exactly the same way. We plug into the x on the right side of the equal sign, whatever given in the parenthesis. So for f of x, you have to plug in f of t. So in this case, that means that we plug in t for all the x. So here is the evaluation. Note that in this case, this is pretty much the same as the original function, except this time we are using t as a variable. If you're plugging in here, you'll be getting square root of t plus 6. That's it. Here is the next example, f of t plus 1. Now let's get a little more complicated, or at least they appear to be more complicated. Things are not as bad as they may appear. However, we will evaluate f of t plus 1 first. This one works exactly the same as the previous part we just did. All the x on the left will get replaced by t plus 1. And we will have some simplification to do as well after the substitution. Here you have replaced x by t plus 1. So a plus b the whole square formula can be used here. Using that identity, you can expand this and then distribute here. So this will turn into t square plus 2t plus 1. And this will be negative 2, negative 2t, negative 2 plus 8. And then you have to finally simplify all the terms. Combine all the like terms. You have only one t square and you have two t terms. So combine it. Negative 2t, positive 2t gets cancelled out. And you have some constants. Combine them all. So I'm getting t square plus 7 as the answer for this part. Please be careful with the parentheses in these kinds of evaluation. It is easy to mess up with them. So work out step by step. So now here is another example. Evaluate f of x cube. So again, let's not get excited about the x in the parenthesis here. Just evaluate it as if it were a number. So replace all x by x cube on the right side. Applying power over power rule here. So x raised to 6 and 2x cube plus 8. Hope you're clear with this example. And one more example for this function g of x. Evaluate g of x square minus 5. So you have to work out this equation. Replace all x by x square minus 5. This is nothing but one more evaluation, and this time we will use the other function g of x. So just expand it. There is no exponent over the parenthesis, so just open it. X square minus 5 plus 6. So finally we are getting square root of x square plus 1. So this is all about evaluating a function. Function evaluation is something that we will be doing a lot of it in the future sections. So please make sure that you can do it. You should have a good grasp on how function evaluation works. This is the basic. In case if you have any query regarding this video, kindly let me know. See you in the next video. Have a great